Let us consider this tiny example. We have a helper at C with an implementation of an addNum function that adds the numbers A and B. And in the main entry point, we call that function with parameters 3 and 4 and return. So the result is 7. And this is what the makefile looks like. Let's try to build and execute. And the result is as expected, that the sum of 3 and 4, which is 7. Suppose we try to define the same addNum function in main.c, but this time we multiply the two numbers, a times b, and we call it here. So we now have two addNum function, the one in main and the other one is in helper.c here. Okay, in helper.c we had addNum and also in main.c. So let us try to build. And we cannot build it. We encounter a compilation error simply because there is a duplicate of the addNum function between in two translation units in two C files. It's not allowed. It's a duplicate. So how do we do this? In embedded systems, there are scenarios where drivers have default implementation which we need to override in our application. So we need to override exactly the same function, but if we didn't do that, then it will take on the default implementation in the driver, such as here in the helper.c. So if we don't override addNum, this will be the implementation of it. But if we override it, then we can define it to behave differently. To do this, we need to use a C language extension from GCC via attributes. So to do that, we need to decorate this function with a weak attribute, this one. So this is not a standard C syntax, but this is an extension to GCC, and I believe it is also the same for clan. So after decorating addNum with a weak attribute, let's look again what's inside our main. We have an addNum here. So let's try to build. And we have successfully built the app despite we have two addNum symbols. We did not encounter a compilation error. And let's try to run it. And the result is different. It's the product of the two numbers. We successfully override the addNum in helper with a new implementation in main.c. This is all for now. Thank you.